Section 5.4 is all about indefinite integrals and net change. So we make the definition that the indefinite integral of f of x is capital F of x. So what we're saying is the derivative of big F of x is little f of x. So basically all we're saying here when we write this integral without limits of integration, there's no a and b here, is that we're trying to find the antiderivative of the function small f of x. So just like we had in the section for antiderivatives, we say all these basic antiderivative rules again, but now we write them as indefinite integrals. So you should know all of these antiderivative rules. Those will be taken as something you'll memorize. There's a note, watch out for the domain, because when you write it out, this is valid on an open interval, so you just have to watch out for the domain. You cannot integrate across places where the domain's undefined. Alright, so let's look at some examples. This first example is just saying what is the antiderivative function of 10 x to the 4 minus 2 secant squared x. Remember, the dx is telling us the variable that we're integrating with respect to, or the variable that is our independent variable. Our dependent variable is x, so we can use the power rule here. So we have 10x to the plus 1 power divided by the new power minus 2 times. We know that the antiderivative of the secant squared is the tangent of x, and then we have our arbitrary constant. So if this question had been in section 5, 4.9, it would have just been find the antiderivative, and that's it, we're done. The next problem, we've got a fraction here, and we don't have a rule that lets us find antiderivatives with fractions, so we need to manipulate this to make it look like something that's more familiar. So let's change this to 1 over the sine of theta times the cosine of theta over the sine of theta, d theta. Now, 1 over the sine of theta is the cosecant of theta. Cosine theta over sine theta is the cotangent of theta, d theta. Now, this looks like the antiderivative of negative cosecant theta plus c. Because remember, the derivative of cosecant theta is negative cosecant theta cotangent theta.